Hello everyone. In this video we will discuss the conversion of CFG to PDA. Okay, so we have two things. We have the conversion of CFG to PDA and we have the conversion of PDA to CFG. So we'll see both the things. In this video we'll only stick to the conversion of CFG to PDA. Okay, so we have a context free grammar and this context free grammar needs to be converted to a PDA. Okay, so let's start doing that. So what we have a CFG. Okay, there is a context free grammar and we need to convert it to a particular PDA. Okay, and this PDA will also be converted to the CFG. Okay, so how we'll do this? So first of all, we know that the CFG has two forms. It is CNF and a GNF. Okay, and the highest form is the GNF. So we'll stick to GNF only. So we'll be having two kinds of languages. One will be a grammar that will be either in GNF or one will be either in not in GNF. Okay, so it will either be not in GNF or it will be in GNF. Okay, so we'll discuss both the things in this video. And in PDA the acceptance is done by two types. One is acceptance of PDA by final state and one is acceptance of PDA by empty stack. So in this video we'll discuss about the empty stack, and this empty stack or the final state both can be converted to each other, that is vice versa. That is PDA by empty stack can be converted to PDA by final state and PDA by final state can be converted to PDA by empty stack. Okay, so this can be converted, no issues in that. Fine. So in this video we'll discuss the PDA, that is empty stack, and the CFG will be one when it is not in GNF and when it is in GNF. Okay, so let's start with this one. So the first one that I'll take will be this, that is not in GNF, and the PDA will be empty stack. Okay, so this conversion is CFG to PDA, which is by empty stack, and the grammar will not be in GNF. So first of all, just to brush up things, what is GNF? Okay, so if we talk about GNF, the productions in GNF is, it will be A tends to small a Vn star. Okay, now what does that mean? That is, left hand side should contain a single variable, right hand side should contain a terminal followed by any number of capital letters, any number of variables. So we can have in this one, including null also. So we can have in this one A tends to small a and capital B, C, D. So whatever we can have, any number of variables are allowed in this one, and even we can have A tends to small a also if Vn is null. Okay, and anything which is not in GNF, so this is in GNF, anything which is not in GNF will be like we have A tends to say small a, capital B, small c. Okay, so this is actually not in GNF. So this is not in GNF. So we'll discuss these kind of grammars first and then we'll come to this one. Okay, so let's start doing this, the first one, that is a grammar which is not in GNF. Okay, so I'll give you a question. Suppose S tends to A, S, B and S tends to A, B. Okay, so we have this particular question, we have these productions, and these both the productions are not in GNF. Okay, that is because we have the small the starting letter is a terminal and the capital letter here is S and then followed by a small letter again. Okay, so this is also not in GNF, this is also not in GNF. Okay, so I'll discuss this. So first, before doing this question, first discuss what are the tuples in PDA, and then what kind of tuples we are representing this in GNF. Okay, so in PDA what we have 7 tuples. Okay, we have Q, we have sigma, we have delta, we have Q naught, Z naught, tau and F. So we have these 7 tuples, that is Q, sigma, delta, Q naught, Z naught, tau and F. So what is Q? Q is a finite set of states. Okay, so Q naught, Q1, Q2, Q3 all will be a state. Sigma will be the input terminals. Okay, delta is a transition function, we'll discuss this later on. Q naught is the initial state, Z naught is the by default top stack element, that is, when the stack is empty, Z0 is there into the stack by default. Then we have tau. What is tau? Tau is a push down alphabet. So whatever alphabets we are pushing in the stack will be a tau, and F is the final state. Okay. Now when we are considering this in the form of a CFG, then we'll have something different. So what kind of PDA we'll consider in this one? Next one is we have Q. So in this CFG, we are assuming that there is only a single state. So we'll write small q here. There is only a single state is there in this PDA. When we are converting this CFG to PDA, so PDA we are getting, it will have only a single state. Okay. Then we have sigma. Sigma will be the same, that is small letters will be the sigma. And then we have delta. Delta is the same. We'll discuss this later on. And then we have q naught. So there is only a single state. So that will also become the initial state. Okay. Now in PDA we have a Z naught, but here in a CFG we have one start element. Okay, so that start element will act as a by default stack element. Okay, so we have S here in case of Z naught. Okay, now we have tau. Tau is a push down alphabet. So what alphabets are being pushed when we are converting a CFG into PDA? Okay, so here I will take Vn union sigma. Okay, that is the elements that will be pushing it into the stack will be either a variable or a terminal, that is either a capital letter or a small letter. So both will be pushed into the stack. Okay, and then we have a final state. So we don't take a final state here, we take a phi here. So we don't have any final state in this one. Okay, so we have 7 tuples. We'll discuss keeping in mind these tuples. Okay, now let's come to this question, that is we have a example. Say this is an example, and in this example we have two productions, S tends to ASB, S tends to AB, and both are not in GNF. Okay, so let's start doing this. So first of all, I have to write the rules for this one. Fine. Now what rules? We have this P. Okay, this P needs to be converted to the delta. Okay, so in PDA the most important thing is delta, that is a transition function. In grammar the most important thing is the production. With production we can generate any kind of strings, and with delta we can accept any kind of string in a PDA. So whatever strings is getting generated with this grammar should be accepted by the corresponding PDA that we are going to design for this CFG, which is not in GNF. Okay, so we have in this one two productions, this one and this one, plus we have some terminals. Terminals are A and B. So I'll write a rule for this production, I'll write a rule for this production as well, plus I will write a rule for the small letter A, plus I'll write the rule for small letter B. So in total we'll be having 4 rules. Okay, so let's begin. The rules are, the first rule is, rule number 1 is for this production. Okay, so what I'll write, it is delta, then I'll write q comma, I'll write epsilon comma s. Okay, so it is q comma epsilon comma s, this s. Okay, is equal to q comma whatever is there on the right hand side, that is we have a s b here. So what does that mean? We are at state q and the top stack element is s and the element to process is epsilon. Okay, so we are processing epsilon, top stack element is s, we are reaching on to state q and we are pushing asb into the stack. Okay, so this is rule number 1. So rule number 2 is for this particular production. So rule number 2 is, it is delta, again q comma again epsilon, epsilon comma again this s. Okay, so we'll write s and then is equal to q comma ab, the right hand side is equal to q comma ab. So this is rule number 2. Done. Now the third one, rule number 3. Rule number 3 is for the terminal. The terminal first one is a, so I'll write a rule for a, that is delta q comma, I'll write a comma a. Okay, so this is the rule, we just have to remember this one, that is q comma a, and for this one what I'll write, q comma epsilon. Okay, so nothing to no logic in this one, we just have to remember this, that is for a terminal we write like this, q comma a is equal to q comma epsilon. and rule number 4 for the second terminal, that is q comma b is equal to q comma epsilon, and we are done. So we are done with the 4 rules. Okay, so in total we have 4 rules for delta. So this is the delta for the PDA. Fine. Now what I'll do, I'll take one string that is generated with this particular grammar, and then I'll try to accept that string in this PDA. If it is accepted, then this rule of the PDA is correct. Okay, so let's check it out. So let's try to generate some string with this one. So what string we can generate with this one? Suppose we have A as B, and again we put A as B here, so I'll get A S B. Again this AB is put here, we'll get triple A and triple B. So the string we can get from this one is triple A triple B. Okay, the language we can get from this one will be A to the power n, B to the power n. So this is A to the power n, B to the power n only. So I'll take this string and try to accept this string with these rules. Okay, if it is accepted, then whatever we have done, whatever rules we have written is absolutely correct. So let's take this string. We have this input tape. Okay, in input tape we have triple A, we have triple B followed by epsilon. Okay, here I will take a so let's take this here only. So first of all, what we have in the stack. So in the stack I'll have S in this one, and the element to process is A. Okay, so we have A. So we'll check it, that is the element to process is A and the top stack element is S. So I'll check in this rule, we have any rule for this particular pair or not. So here if you see, we have for S we have 2 rules, that is we have this rule, we have this rule. Fine. So since we have 2 rules for S, therefore the PDA that we have designed is a N PDA. Fine. So for the same input we have 2 outputs. Okay. So anyone I can take. So machine will actually take both the inputs. Will use both the rules. But if I see manually, if I see, so I know I have to take this rule. Okay. This rule I'll not take. But the machine will take both the rules and it will check for both the rules. So let's take both the rules only. So one rule is for this one for this one. Okay, now for this one we have this S here. Okay, and I'll make a stack for both the things. Okay, so what we have here, that is it is saying when the top stack element is S, okay, then and you don't have to read any string, that is you have to read only epsilon. So you don't have to read any string, that is I'm not reading this, I'm not reading this A. What we have to do, we just have to simply push A S B into the stack. So in place of this S, A S B will be pushed into the stack and this pointer will not move on to the next A. Okay, so what I'll write here, I will write A S B here and this pointer will not move on to the right hand side. Okay, this is for this rule. And if I take this rule, so what will happen? For this, I mean, what it is saying when the top stack element is S, then you don't have to read any input, you just have to read the epsilon. So I'll read the epsilon and you in place of this S, you have to push AB into the stack. So in place of this S, I will push AB into the stack and the pointer will remain on this one. Okay, pointer will remain on this one. Clear? Now again, now the element to process is A and the top stack element is A. So I'll do this separately. I'll do first for this one, then I'll do for this one also. Okay. So the element to process is A, the top stack element is A. So A comma A. So what we'll do? We have one rule for this one, that is A comma A. That is the element to process is A, top stack element is A. What we will do? We just have to simply pop the A out. Okay. So the pointer will now move on to the next A for this one and this A will be popped out. Again, I'll make an input tape for this one also. So for this one we have triple A, triple B, pointer is currently onto the first A only. Okay, so I'll do this later on. Now again, the element to process is A, the top stack element is S. So again, as soon as we see that the top stack element is S, what we do, we don't have to read the input symbol, we just have to push either this into the stack or this into the stack. Okay, so this time I'll not push this one, I'll push this one only. Okay, so what we'll do, this it will not put forward, I mean this pointer will not move on to the right hand side, and in place of this S, ASB will be written. So what we'll get? We'll get ASB followed by B. Okay. Now the element to process is A and the top stack element is A. So we have A comma A. Again for A comma A, what we have? We have epsilon, that is this A should be popped out. So this A, this pointer will now move on to the next A and this A will be popped out. Fine. Now again the top stack element is S. So again we have two rules, this one and this one. So I'll not take this one, I'll take this one this time. Okay, I can take both one, the machine will take both, but if I see it with my logic, I know that we have to push AB this time, that will be the correct one. Okay, so what it is saying, we don't have to read the input symbol, we just have to push AB in place of S. So next what I'll do, we have S, so S in place of S, AB will come and then followed by two B's. We have two B's now and the pointer will be on to this A only. Okay. Now the top stack element is A and the element to process is A. So for A comma A, again we have a move, that is we have to pop this out. So this pointer will now move on to the next B and this A will be popped out. Fine. Now the element to process is B, the top stack element is E. So for B comma B, we have one rule, that is we have to pop this B out. So 3 B's and 3 B's will be popped out and finally we are at epsilon and the string is done and the stack is currently empty. So the string that we have triple A triple B is accepted by this particular PDA. Therefore this PDA seems to be correct. Okay. And of course this will be a wrong one. Why? Because we have AB here, the pointer here is A. So for this A and A, this will be popped out and the pointer will move on to the next A. Okay. So again A comma B, we don't have a move for this one, that is A comma B, we don't have any move here. So this will terminate here at this point and it will not proceed forward. So this will be the correct path and we have made sure that these rules are actually correct. And why? Because we are accepting this particular string with these rules. Okay, so this is for a CFG to PDA when the PDA is an empty stack and the CFG is not in GNF. Okay, so now let's discuss the next one, that is when the CFG is in GNF. Now before going on to the second example, that is the conversion of CFG to PDA when the CFG is in GNF. So first of all I'll see how stack is represented when we are converting CFG to PDA and the CFG is in GNF. Okay, so in stack what we have Q, we have sigma, we have delta and tau and Q naught and Z naught and F. Okay, so this is normally in a PDA, but we are converting this CFG to PDA. Then what we'll have in here, we have small q, that is we'll be only having a single state. So we'll take Q, then sigma will be same, then we have delta will define the rules next, and then we have tau. Now in the previous case in tau we took V and that is variable and terminal. In this one we'll not take terminal, we'll take only the variable. Okay, so we'll take Vn here and then Q naught, because there is only a single state, we'll take only Q. Z naught will take S here and there is no final state. Okay, so these 7 tuples will take in this category. Okay, so we have Q, we have sigma, we have delta, we have Vn as the push down alphabet, we have Q, that is the initial state, we have S is the start symbol that will be there in the stack, and we don't have any final state. So we'll consider this one. Okay, now let's take another example that is in GNF. Okay, the example is we have S tends to 0 B B and we have B tends to 0 S slash 1 S slash 0. Okay, so we have 4 rules in total and all the rules are in GNF. This is in GNF, this one is in GNF, this one and this one, so all are in GNF. Okay, now we have to convert this CFG into the equivalent PDA. Okay, so let's define the rules for this one. So in total we have 4 productions, therefore I'll define 4 rules for these 4 productions. Fine. So rule number 1 that we have is, first one we'll take delta, that is Q comma 0 comma s, 0 comma s, what I'll get? Q comma bb. Okay, so I'll get Q comma bb, Q comma bb. Okay, rule number 2, delta, we have Q comma, for this rule, Q comma 0 comma b, Q comma 0 comma b is equal to what we'll get? Q comma s, Q comma s. Now for this one, the third one, that is delta Q comma 1 comma b, 1 comma b, and we'll get Q comma s, Q comma s. And the third one, the fourth one, delta Q comma 0 comma b, 0 comma b, what will get? Q comma, what is here? We have epsilon here, so Q comma epsilon. Okay, so these are the 4 rules that we have defined for this particular CFG. This is the delta for the PDA. Okay, now I'll try to generate some string with this one, and that string, if it is accepted by this PDA, if the PDA can accept that string, that means the rules that we have designed for the CFG for this particular PDA, it is correct. Okay, so let's design some string with this one. So a string that we can have with this one, it will be like 0 1 0 0 0 0. Okay, so we can have this kind of string with this one, 0 1 0 0 0 0. Fine. So I'll just try to check this whether it is accepted by this PDA or not. So the elementary process currently is 0, and I'll make a stack here. In the stack, what we have s initially. Okay, so the elementary process is 0, the top stack element is s. So do we have any rule for this one? That is 0 comma s. So I'll use this first rule. It is saying in place of s you have to write bb, that is we have to push bb in place of s. So what I'll do, I'll move on to the next one, and this will be processed, this will come on to the next one, and what we'll get here, we'll write bb here. Okay, so now the elementary process is 1 and the top stack element is b. Fine. So for 1 comma b we have this third rule. Okay, what it is saying, in place of b we have to push s. Okay, so I'll do this, this pointer will now move on to the third one, and what I'll get this one, that is in place of this b I'll push s, and we have got sb here. Okay, now the elementary process is 0, the top stack element is s. So we'll use this rule. We have this rule. Okay, that is we have to push bb in place of this s. Okay, so next one, this will be processed, it will move on to the next 0, and what we have here, in place of this s, bb will be pushed. So b, b, and 3 b's. So currently we have now 3 b's. Okay, now the elementary process is 0 and the top stack element is b. So 0 comma b, do we have any rule? Yes, we have 2 rules, rule number 2 and rule number 4. So because of this one, it is an NPDA. Why? Because we have 2 rules for 0 comma b, 0 comma b. Fine. So it can write, in case of I mean if I use this rule, then in place of this b it will push s. Fine. And if I use this rule, then in place of b it will pop the b from the stack, whatever element is there it will pop out. Okay, so if I see manually, I know that this rule will work for me. Fine, but the machine doesn't know that. Machine will take both the rules. It will follow this rule also, it will follow this rule also, but this rule seems to be incorrect. So somewhere down the line it will go and terminate without emptying the stack. But this one, which seems to be correct to me, it will somewhere go to, down the line, and finally everything will be popped out and the stack will be empty. So we are making a PDA, and the acceptance will be done by empty stack. So when the stack is empty, we are done with the acceptance. Okay, so I'll use this particular rule, that is second, I'll use this rule, sorry, fourth one, that is whenever we are reading the element 0, top stack element is b, we need to pop this out. Okay, so we'll pop this out, and this will move on to the next 0. Again we have 0 comma b, elementary process is 0, top stack element is b. Again we'll use this fourth rule. Again it is saying that we have to pop this out, and this will pop out, and we'll move on to the next 0. Okay, so next 0, the elementary process is 0, top stack element is b. Again I'll use this rule, and this b will also be popped out, and the pointer will now point the epsilon, and the stack is currently empty. Therefore this string is accepted by this particular PDA. Therefore, we can say the rules that we have designed for this PDA in order to convert the CFG to the PDA are absolutely correct. Thank you all. Thank you very much.